There's a common idea in finance and investing where there is volatility, there is inefficiency in the market, which means there could be an opportunity for greater returns. That's not always the case, but in this video, I'm going to show one way of testing that theory and go through the code and how it works. So we're going to be assessing the stock market inefficiency based on volatility. And we're going to be using a lot of the usual suspects here, but I want to point out the Spearman R package that will measure the p-value of a of a given how would you say the p-value if it's less than zero point 0.5, for instance, um, then that's like saying that there is that you can reject the null hypothesis. So our hypothesis today is there is a there is a causation between volatility and market returns, and we will measure whether there is a statistically significant correlation there to accept or reject the hypothesis. So first we have to set it up and we import all the packages we need. We'll be using this stock portfolio here. In previous videos, I found that this one created the greatest returns, and it's just like a random selection of S&P 500 stocks. So you see we have like Home Depot, Gold, we have Eli Lilly here, Bank of New York, etc. And we just download that portfolio. We stack the indexes so that it's by date and ticker. We reorder the levels, we drop duplicates, and we get this data frame here. So we have our first ticker for all the dates, etc. So we want to calculate volatility, and in the tutorial I was following, they were using this Parkinson volatility calculation, which just shows that instead of taking the standard deviation between one day to the next, you can actually find greater information by taking the data between the high and the low and taking the standard deviation from that, essentially. And then there's some more rolling window volatility type calculations here as well, but this function just calculates what's called the Parkinson volatility. And we apply that to all of our tickers. And so I'm just grabbing a random sample here, and you can see here's the volatility going negative in that instance. Next thing we do is we set up lags. So with the volatility, we have like a return 1 day, return 5 day, return 10, 21, 42, and 63. And these lags help us reduce data leak. And we're just calculating the return with a pretty simple percent change based on the lag day that we want. And then we shift the actual returns down to the target. So for instance, like we need our returns to match with our actual like days that we've calculated. So like we need to know what the target return is for this day here, etc. And the returns calculated as is wouldn't give us that. So we need to shift it back so it matches the actual time frame. So we do that, and now our data frame is like really long. So we've got our open, high, low, close, our volume, our volatility, our return calculations on the lag, and then if I keep scrolling over here, we have the target as well. And then here we go. We're gonna create a joint plot, which will visualize the distribution of the returns to our market. So our metric is volatility here, and our target in this instance is a target 1 day. So what we're asking here is what is the statistical correlation between the volatility to the target 1 day for our data frame here. And you can see it came up with 0.018, which is really, really low. So this is saying, and you can even visualize it here, that the volatility really doesn't have any linear correlation to the target 1 day return. So we would reject the hypothesis that states that this market is inefficient or that the volatility has some causal correlation to the target 1 day return. But we can do this for a longer set. So when we look at the target 42-day return to volatility, the correlation is higher, it's 0.1, but I'm pretty sure in statistics, like you wouldn't consider it statistically significant for anything under 0.5. So this would still be something that we reject and say, although there is a greater correlation here, it really doesn't give us, we really can't state that volatility leads to greater returns, even on a 42-day basis. And I've opened up a little Ko-Fi here. If you guys really enjoy these videos, this is the best way to support me. I can't go to it right now, but if you follow this link, you can support me. You can put in any amount that you feel like. Of course, this is all free. If you don't feel like you want to provide money, that's totally fine, but it does go a long way in helping me keep these videos rolling. And it also prevents me from shilling out a course or Patreon. That's just not really my style. So I just really appreciate you going here and checking it out if you feel comfortable enough to do so. Anyway, we're going to do other videos like this because assessing a stock market inefficiency, especially when we're looking at stocks in the S&P 500, I wouldn't expect there to be returns based on volatility there. But let's see if we can find something where there is. And so stay tuned for other videos to come. Thanks for watching.